My name is Semra. I'm from Boğaziçi University. So as I just told you, I'm going to present on behalf of my student, Serdar. So this is a very, very small portion of our large project we just completed. So our initial aim actually was to predict the anomalies which may lead to accidents on the sites by using the physiological data. And to support the physiological data, we were thinking that actually the exact position of the workers within the construction site is very, very critical. And in this regard, ultra-wideband technology is it's not that expensive anymore, sensors, but it has a huge advantage in terms of providing the accurate centimeter close accuracy for the exact location of the workers. But then, due to the challenges that I'm going to explain right now, we change our mind and we are just focusing on right now to the physiological variables and the IMU, which is the Inertial Measurement Unit, which is actually measuring the body movements using the gyroscope and the accelerometer. So the problem, as you all know, construction industry is the most hazardous industry, and traditional safety monitoring methods actually focus on the human observation, and which is not practical anymore on large and complex construction sites. Yet we have the technology right now in terms of monitoring the real tracking of construction workers, and we can do that by using several technologies, tracking technologies such as ultra-wideband and IMU. So, as we see these two most popular actually sensors, the technologies that when it's time to monitor the workers, usually people are asking which one's better, okay? But I think this is not the right question because both technologies gives an answer to a different question. Ultra-wideband technology actually shows us where the worker is, while IMU technology is actually answering the question, what is the worker doing? So the philosophy is quite different between these two technologies. So in this study, we compare these two approaches as standalone systems. So let's look at the characteristics of ultra-wideband technology a little bit. So it's under the light of site condition, it can achieve centimeter level accuracy, but once again, it has lots of disadvantage. The main disadvantage, the setup, okay? The sensor is so cheap, but the maintenance is expensive. First of all, we don't have the electricity wired during the construction site, so, and we need energy for the anchors. So you need to first of all set up the anchors, and the battery has a certain life, so you need to replace them when it's necessary. So the maintenance is a big issue, but even more important than that, unfortunately, the walls, the steel structures, concrete actually blocks the signals, which reduces the quality of the data that you are getting. So these are the main limitations, but the main advantages, you know exactly by centimeter closeness, know where the worker is. IMU, it's very cheap. All of you have the IMU right now. You're all carrying smartphones, and we can access from your smart watches, from your smartphones, your accelerometer, and also gyroscope data. So, and we can, using the machine learning algorithms, which I'm going to tell in a minute, using the IMU data, we can actually predict the activities that are performed. So that relative tracking only, so not absolute positioning is provided using IMU, and accumulated sensor noise and the vibration distort the trajectory over the time. So these are some little disadvantages that we can talk about. So what is our objective? Definitely not to declare which technology is the winner, okay, because both technologies has different aims here. Instead, we want to understand the practical trade-off between them, okay? And we evaluate both systems under to be able to do that, we evaluated these systems under different working conditions. We examined the practical trade-off between the location-based positioning and the motion-based recognition. And how did we do that? We conducted an experiment. For the purpose of this conference paper only, we are just sharing the data from 5 participants, but then we extended it to 43 participants, so we have a much larger data right now. So in a controlled structural engineering laboratory at Boğaziçi University, 5 male participants aged between 25 and 60 participated. We used 2 iPhones and we locate them at the lumbar, and one of them just put them in their pocket to track the IMU data, and we placed the ultra-wideband on the hard hat, as you can see from the pictures. And we also placed 9 anchors around the laboratory, and the one that on the hat set work as a tag. So now we collected data. What is next? So for the ultra-wideband pipeline, we don't need machine learning algorithm because it's rule-based analysis is enough. Why? Because we have the we basically have the workers classified into their predefined spatial zones, and from the ultra-wideband sensors, we know the exact location. And this zone is already defined with a certain mezzanine, plank, or the normal work area. So it was very easy part. So the difficult part was the IMU pipeline, because we collect data, gyroscope and accelerometer data, so we somehow need to analyze it, train the algorithm to understand which activity the workers are doing at that time, basically. So in order to do that, we obviously need the ground truth. So how did we get the ground truth? We recorded any video, and we synchronized the video with the IMU data using the Unix timestamp. And then we manually, not we, okay, to be honest, my students did that, manually labeled them. So for 5 workers, it was easy, but for 43 participants, it was a huge work, and I really do appreciate their effort in that regard. So because each experiment took like more than 35 minutes, so we had a really long videos, and Elan is actually a transcription software which works really well in terms of labeling. And then we divided the data into 2-second windows with 50% overlaps, and we identified 13 features to train the algorithm. We tested several machine learning algorithms, and among them, random forest performed the best one, and we also evaluated the model with the leave one subject out cross-validation. Before going to the results, we immediately eliminated the data coming from the pocket as consistent with the literature. The lumbar, since due to the body center of the mass, we continued with the data collected from the lumbar. So as you can see, actually accuracy is very high for both cases. So you may think that IMU is also doing really well, as good as the ultra-wideband, because it has an accuracy higher than 80%. But I want you to take your attention to macro F1 level. So since the majority, we have an imbalance classified activities, and the majority of them is the normal work, so it makes sense that we have very low macro F1 for the IMU, and ultra-wideband actually has outperforming in this regard. For example, in the IMU, weight and scaffold walks misclassified as normal walk due to the lack of spatial awareness. But you can eliminate those kind of issues when you use the ultra-wideband technology, so we can precisely, 99% almost, correct the difference between the ground level and the mezzanine level. So what is the trade-off? The IMU detects activity dynamics, so it can really identify well if you're trying to balance while working on the plank, and ultra-wideband detects the general zones perfectly. And I'm on time, right? And the practical deployment, the ultra-wideband, high upfront, not the upfront cost to be honest, but the maintenance cost and the challenge during the maintenance is a problem. Also, georeferencing is another issue. You need to know the exact location of the anchors, at least one of the anchors, and from there you take it as a reference point and you place the other, the anchors. So it also requires some extra devices to place them. And it's requires consistent recalibration. For IMU, once again, no cost, but it doesn't give you the exact location. Highly scalable across continuously evolving multi-story sites. So paper's direction is to monitor ultra-wideband's quality in real time. So if you set up this technology, but if you're asking my personal opinion, I think unless it is very critical and necessary, I would not use it. Maybe you can just use this technology for some certain very vital areas where it is very, very critical to know the exact location of the workers, because we have other technologies available for predicting a rough estimate, or at least, for example, outside GPS works really well, but at least if you want to know the level of the in which store the worker is working, you can use the RFID or other technologies. So use the ultra-wideband when the localization is reliable, and you can switch between the IMU, and ultra-wideband when it becomes unreliable. So the key limitation, IMU spatial ambiguity, ultra-wideband's vertical noise, and so the takeaway is these are the complementary technologies, so I cannot tell you which one of them is better or the winning one. Okay, thank you very much for your attention.